Testing. There we go. I just left the microphone unplugged so that the Russian security agents could not attack me. Is the remaining work in the compiler confidential? No. All right, the honey bear situation is much more tractable. Although, honestly, I think I understand why honey bears are not more popular. How many levels does Sokoban have? Around 700. Are procedures parsed and type checked even when they are then eliminated as dead code? They are parsed. They are not type checked. Microwave the honey. Yeah. Microwave the honey. So right now I'm just doing string comparison as a built-in, because for the entire life of the compiler till now, it has been a case where when you see two strings being compared, we call a function that happens to be in the preload. And that's probably both slower and uh, has fewer gains Weisman score wise than doing it inline. So we're doing it inline, and I mean, this is also important because strings occur quite a lot, right? But it was very convenient to do it the previous way, or at least it was for a while, especially way back when we transpiled to C. It was just very easy to call some C function that did the thing. Now, it's probably not a very good strategy for the level of completion that the compiler is now in. Yeah, dead code elimination was huge. Dead code elimination was massive. Is there an opcode that does string compares? Yeah, sort of. There's this thing. It's like rep comp SB or whatever, right? The thing is, you don't want to do that if you can avoid it. Fortunately, for the way strings are stored here, so if for no other reason, this involves dereferencing the data pointer, which again is cache unfriendly and all these things. So we can actually check if the counts are not equal, the strings are not equal, right? If the data pointers are equal, right, the strings are equal. And that includes, so two empty strings or whatever. Usually empty strings have a data pointer that's null, so this would catch it. This is wrong. This should be JNE right here. Okay. And then the thing that I forgot about is this. I have memcomp right here. Okay. Yeah, we should actually compare with 0. So this is going to be where is it? We have it in RA count and RB count, which are actually RCX and stuff, but okay, so hold on. This one can legit be a JEQ. There's probably something I can do here to reduce the number of branches, but initially I just want to get it working. So we need to fix this up, but we do some kind of branch here. We do a jump if equal. This is only if the counts are not equal and non-zero. Then we resort to comparing the data pointers. Could it be unintuitive that eliminated procedures are not type checked? Well, we already have that because polymorphic procedures are not type checked. Now, I was thinking that I might have dead code elimination be an enum so that by default, your main program doesn't get it. And so you're type checking everything all the time. We'll see. We'll see if that makes sense. I oversteeped my Singapore breakfast tea a little bit. Very sad. That's where the honey bear comes in, though. If it's only a little bit of oversteep, honey bear and milk can help us out. Is there a date for open beta? There is not. We're simply going to try to get it out there. Okay. We do the compare. We set CC. If they're equal. We jump if equal. This is true that this is a jump if equal. Okay. This should be JNE. The rest of these are fine. Okay. Let's go talk to Felix. What does Felix say about JNE? If not equal, 7.5. Okay. Okay. So we got branch 1, branch 2, and branch 3. Ugh, but still better than calling a function. A function that would have all these branches in it anyway, I mean. Branch 1, 2, and 3 all go to the same place. Yeah. Hold on. Okay. Okay, so we're not using any of this yet. This is just prep. I feel like I'm using more registers than I need. Because RB count can be an RCX, right? Or no, RA count is in RCX. Hold on. RB count and RR. Yeah, okay. So I need RA, RB, because I need to dereference them. I need a count for each of these. I actually don't technically, because I could do... Okay. Right? No, we can't exactly use RCX. Maybe. Okay. So, again, we compare. We load the counts. We compare. We set, are they equal? If they're not equal, that's 0. And we go to the end. Okay. If strings are 0 length, they're equal. So we compare RA with 0. If they're equal, the strings are equal. We didn't do the set CC. Okay. We compare, or we load the data pointers. We compare them. If they're equal, we almost might as well not do this part. I'm not sure. Okay. Anyway, we load the data pointers. Are they equal? If not, we do the memcomp. Sure. Sure. Okay. So we're just going to, before we even try to use these, we're going to verify that we didn't break nothing too bad. And then check it in. Okay. Commit. Getting ready to use string compare bytecode instruction. Okay. Well, let's start using it. Do we actually substitute this? Do we actually substitute this in the type checker? I think we do. Which is kind of gross, I'm not going to lie. Proc strings are equal. Oh, we have a compiler intrinsic for this. For some reason. Make string comparison call. Yep. Oh, God. Okay, so let's get rid of all this. We're going to break things. Okay, this also means we can do string compares in the preload now after we finish this, which is also good. Strings are equal. Boom. Right? Yep. Okay, runtime support. Strings are equal. Strings are not equal. Okay, great. While I'm doing this, string comparison is now built into the compiler. This results in faster generated code and smaller programs. Did they have underscores? No. Function strings are equal, strings are not equal have been removed from runtime support. If you want one of these in function form, you can just declare strings are equal. Okay. Okay, well, that's a statement of what we have to make function correctly. Okay. Just going to ignore that because that's obviously no longer proc strings are equal, proc strings are not equal. Compiler strings are equal, compiler strings are not equal. Compiler strings are equal, strings are not equal. Compiler strings are equal, compiler strings are not equal. Make string comparison call. Dunzo. Okay. Make string comparison call. You are gone. Make string comparison call. Okay, we're going to need to figure that out. And then we're going to need to figure that out. So one of these is the switch statement. And then the other one is the regular. So here, yeah, let's just And then the back end will have to handle this. Okay. Now. Wait, what? Why is it giving me it? Oh, it's the wrong file. Make string comparison call. So, doing strings. Oh, because the call. Why did we ever do this separately, differently? So the case statement I don't like any of this. Okay. Doing strings. Yuck. Yuck. Okay. So is switch statement. Okay. If it's a switch statement, that's pretty normal. Inferred cases. Oh. Okay, so okay. Really, we did want the doing strings. Because we just want to use it in a much simpler way. All right. Diff. Doing strings. Yep. All right. Just making sure we don't somehow not do relative strings. Okay. All right, I got to fiddle with my temperature here again. Okay. So if we're doing strings, we just do something different. We want to do string. Strings are equal. Condition register with write register to compare result. Let's not call it compare, because that might lead someone to think it's -1, 0, or +1, right? So I don't know. If we want to jump if equal, right, okay, this is why it was opposite. Okay. Jump if equal -1 -1 are equal result. Is that right? Jump if 1. Yeah. Well, I feel like I didn't do something. Oh, we didn't ever really generate this for bytecode builder. What? What is my token for is equal? Bytecode compared to, right. Okay, boy, we could be breaking a lot of stuff here. This is fun. Okay, if these are strings, generate a string compare. Okay. If we're doing strings, otherwise, we do this integer compare stuff that we did. If we're doing strings, okay. Okay, something like that, guys. Okay. So unknown argument in process args. Okay. That means the bytecode builder is not working. Or sorry, the runtime, either the string compare in the runtime engine does not work, or we're generating incorrect bytecode. And I'd put my bet on the latter, but it could be either. So we are now going to go start dumping our meta program. Oh. I don't remember what this was anyway. We'll look at that later. Okay, command line arguments. Wait, was this... Why was I doing shared memory? I don't even know. Okay, anyway. So we're going to dump this out. And, oh, it's the case statements that are wrong. That's no surprise, really. Okay, so let's dump it. All right. Okay, we have this thing. we have this thing. We can look at this switch statement on line 1084. Oh, we want the debug compiler because that'll give us more line number information. Guys, I'm going to be out of sun chips in like 2 days. It's crazy. Okay, as we were saying, line 1084. Here we go. Switch statement. We make this string constant, v37, v38, and then that is in v36 is like the address of that string. And then we're asking, are the strings equal? We jump to 5 if they're not equal. Otherwise, we do all this stuff, which seems like a lot, but I think this is the remove statement in here. It probably could be shorter. Yeah, this is subtracting 1 from the iterator count. And this is subtracting 1 from the array. What's my sun chip power ranking? I only have 3 flavors here. I have blue, orange, red. And I think red is the best. Orange is the second best, and blue is the third boringest. Although the boring is nice sometimes. I would try moon chips if they made moon chips. Okay. This looks fine to me. Which is surprising because I would have guessed that this was what got screwed up. We don't have a Weisman score target. It is just to get it as low as possible. Okay. That kind of seems fine. So I'm going to break in the execution and see if I screwed it up there, which come on. Okay. So we're going to check this. Okay. We're checking A and B for equality. A is test, B is print like. They should not be equal. Boom, they are not. A is register command. Oh God, we're going to do all these. Let's actually, okay. Let's test this. No profile and print like are the same length. We won't do this. We're mem comping. Oh, I got this backwards, guys. Congrats to me. Happy birthday to me. Happy birthday to me. Happy birthday to the compiler being able to run again. Except not. Unable to find Windows kit root. Can't compile. Why are we there? And then why is the compiler not exiting? Okay. Well, happy birthday to you as well. How much of the work on a piece of code is the compiler already done before it gets rejected? A very small amount. Lexical analysis and parsing are very cheap compared to everything else the compiler does. Do I use anything from STD? No. I did on one project use std : function because that was how they say that you can use lambdas at all. But then you can get a replacement for that that's slimmer. Okay. Unable to find Windows kit root. So this is weird. Like, okay. It sure seems like this would have been the last failure point. So, like, I don't get it. But it might be a code generation error. If the switch statements are okay, that might mean the vanilla if statement is not okay. Okay, find Windows kit root. Oh, gosh. Why are we in run custom link? Did we do that? We do use custom link command. I guess it's to keep it working. All right. Let me just do some simple stuff just to narrow things down. Wait, hold on. I never promoted this to a test. Using through pointers. All right. Add tests. I don't know why completion is not working. It's just computers. Okay. Okay. Yeah, okay, I don't have to add that manually. That's great. Okay, so now we can destroy this program. Okay, it's no surprise that X6 or LLVM doesn't work. We didn't even finish that. Not equal. Okay, that is bad. Equal. Okay. So it's the x64 code that's wrong in this case, but that's not going to help us build. But I guess we should step through the x64 now and figure out why it's wrong. Let's do that. I mean, it doesn't really matter in what order we fix things. Like, anything tractable is good to me. All right, so we're going to step into... All right, we're going to go in there. Go down. I love how they just assume that nobody would ever want to keep the assembly language output up, so they just fucking don't. All right. All right. So A is hello, B is hello. These most likely work just fine. All right. A is equal to B. RCX R13. That's wrong. What? Did I not load the register valve? Yeah, I didn't. I just didn't load them. So if you want to succeed in the game industry, don't be a loser. Really? Okay. Well, that pushed us over the line. There we go. They are equal. Okay. How do I want to do this? Okay, C dot count is 5. That's great. And then I want to do length 0. Okay. Seems plausible. Okay, this seems like I screwed up something in the compiler or something. Or maybe just something in file utilities doesn't work. Let me do, okay, just to be paranoid, I don't think this is the problem, but I'm just going to do a rebuild. Because sometimes when you change a header file, Visual Studio doesn't recompile everything that depends on it, and then you're sad. Does it work with C.data null2? Probably, yes. I mean, we could test that. Okay. So what do I do next to debug this? I guess is the question. Aside from run my newly rebuilt compiler and find that that did not fix anything. We can look at what it's trying to do. Okay. I guess this doesn't get flushed. Great. So the string output is not there. Okay. Let's visit files, visitor proc. Okay. Unable to find a module called output. Because there's an output dot in the folder. So whatever is trying to look at the suffix and say, is it a known file type? It's probably not right. So it's this. Oh, guys. You know what I didn't do? Do you know what I didn't do? So there are, in fact, two binary operators that operate on strings. There is equal equal and exclamation point equal. Now, the bytecode builder is like the honey badger. It doesn't care right now. Okay? Remember what I said about not being a loser? So it's all about equality. It is very progressive. Yes. Okay. Okay. Guess what our test didn't test? Okay. Okay. How do we do that in x64? We might be able to do the same trick. Let's rename that. Okay. So set CC equal and set CC not equal are off by a 1-bit, guys. How great is that? Yeah, I think so. Because the set CCs are the only things that produce the values. Okay. Okay, we just exit now. So we could do all this stuff again. I don't know. Here, let's do this. Screw it. Let's not complicate it. Just not involve any other compiler features. Hey, look, guys, I'm writing 1,000 lines of code today. I'm very productive. I am the most productive programmer in the world. Oh. I mean, that worked on both of them, which means we probably have a different problem. I mean, how many lines of code did we just write? 100. I mean, that's pretty good. Oh, well. Now, what's interesting is that didn't seem to get us gains. And I guess it's because, or it didn't give us Weissman score gains. Probably because call counts as one instruction. It's just massively more inefficient at runtime. Probably. Yeah, it gave us a small amount of gains because we deleted the functions from runtime support. But so I guess I assumed this would be more Weissman gains, but it makes sense that it's not, because whatever the arguments to the call would be, you still have to marshal those to do the inline compare. So this is hopefully just output code efficiency. All right. Does it run though? It does. Good news. Good news. Now the test program might be invoking LLVM. I feel like it doesn't correctly use x64 all the time when I tell it to. That might be the problem. See, because here it says compiling. Yeah, I don't know. It doesn't put the x64 on the first one, which is weird. Check frame rate. Oh, yeah, we could check the frame rate as soon as this is done. All right, well, if that's done, then all we have to do for this to be done is to make it work in LLVM, which, as we know, can take 7 days. Okay. I feel like the frame rate's not going to be that much better. That's a little better. I mean, it's back up. It was sort of more evenly split 17 to 18, but now it's more in the solid 18s. The thing is, the reason I was saying before it came up that I don't think it's going to be that much better is, like, in a 3D video game, you try not to do a lot of string compares in the middle of the game. Like, string compares are something you might do when loading assets a lot or something, right? But you don't want to do a lot of string compares. It is to be avoided. So that is the expected result. Now, got to make this work on LLVM. I played the main part of N Step Steve Part 1. I didn't get all the stars. I actually don't like it as much as 5 Step Steve. Dyson Sphere program. I have not seen that. Okay, this part does not look good, but yeah, okay. We'll give that a try. We'll give that, thanks for the note. All right, I'm going to re-up my tea here, and then we'll keep going. We have a pretty good Weissman score, I gotta say. If it doesn't go any lower, I'm happy. We have very far exceeded expectations. Auto hide is an anti-pattern. Don't ever auto hide. It's bad. Do I think stuff like Doxygen is useful? Yes, it is useful for destroying civilization and making programmers miserable and turning software into garbage. That's what it's useful for. What's the reason for doing your own x64 backend? Because I program software. I don't rely on everybody else in the, like, there's this whole cast of programmers now that want to believe that they are programmers, but also will adamantly tell you that their job is to just write functions that glue together code that other people wrote. And they don't ever want to actually write the code. They just want to write the functions that call the actual code. And the more your software consists of that, the more you destroy civilization and turn everything into garbage. Why is auto hiding an anti-pattern? Because it interferes with the perception action loop and adds latency and causes delay. You started Python last week, and now you're able to understand what I'm doing? Well, that's some impressive progress. What about KISS and DRY and whatever? Like, look, if you're at the point in programming where those acronyms seem important, that's fine. But like, advanced programmers don't think about those things. They have their style that they've converged on that they know works, that may share some things conceptually with what those acronyms talk about. But like, people who are advanced, experienced programmers who have done a lot of real work don't go around saying the programming acronyms, you know? I mean, if you like auto hide, don't let me tell you not to use it. But I don't think it's so. The reason I have this on the side is that computer monitors, generally speaking, went through a giant anti-pattern. Computer monitors used to be much more useful for programming, just like everything. Back in the day, when they were aspect ratio 4:3, because that meant that you could have more vertical text for a given number of pixels, right? Then, because televisions converged on 16:9 aspect ratio, then computers' displays started going widescreen to 16:9, or sometimes, thankfully, 16:10, which is better. But now for a given number of pixels, you don't get as much vertical text, which kind of sucks. But then also, it's not quite wide enough to really have two things side by side in a nice way. Like, you kind of would like it to be wider, actually, if you're going to do two, right? And so 16:9 is in this really horrible spot where it's either not tall enough or not wide enough if you want to do actual text. And this is not just programming. This is like reading web pages, whatever. Like 16:9 is freaking terrible. So you either want wider or higher than 16:9. Unfortunately, 4K monitors are 16:9, and that's what this is. But at least the 4K gives you more pixels. Anyway, so if you're going to have a taskbar, which, by the way, it's stupid that this taskbar is this fat. It's got way too much wasted space. If you're going to have a taskbar on the side or the bottom of a 16:9, you can either make your vertical space problem worse by taking away the bottom space, right? Or you can make the horizontal problem worse by taking away this space on the side. If you make the horizontal problem worse, it's proportionally not that bad, right? Because you're taking a little bit away from 16 as opposed to taking a little bit away from 9. Do you know what I'm saying? But this is also why all these garbage, like if we just start the debugger here, like this layout is just complete garbage because they use up so much vertical space out of the 9. Like the amount of actual space that I get to do anything with is too small. It's actually not as bad on a 4K screen anymore, but on my laptop, these things are so huge and fat that it's awful and I can't see very much, right? My laptop's 1080. No, my laptop's 4K also. It must have like a different display scaling setting. You can move these around. No, moving around doesn't help. I want them to not be there. Okay? Like, look, this is stupid. Look, there's an entire top thing that says call stack and all this, but then all this is at the bottom and it says call stack. Just move these tabs up here and get rid of this, right? It's like whoever designed these things is a failure at design. That's all I'm going to say. Hopefully they've improved since they've done this. Let me put it that way. But probably it was designed by committee and whatever. Yeah, I wish I had a screenshot of what my laptop looks like because it's so much worse than this even. The honey bear is giving me a problem getting the honey out. Let's prop it up for a minute. The panels probably calm things from 1990 that no one understands anymore. No, they rewrote the whole thing in C# in like 2006. But now that's ancient. So anyway, I would like a monitor that I guess is taller. Like 16:10 would be better. You know, something wider. I guess there's like someone was talking about 21:9 or something. That might be better for programming. I don't know. It's so weird. It's like 16:9 is not even a good aspect ratio for watching movies because cinema cuts are wider as well. So like it's really a mediocre middle resolution that isn't that good for anything. Like I'm not sure why they picked it. Yeah, 4x3 displays on older laptops were really nice. That's the thing with 16 by 9, you make your laptop bulkier and you can't use the screen space effectively because it's a weird shape. It's such a huge fail. Like it's uh and then you're paying battery, right? You're paying battery to power this screen that you can't use that effectively. And you're paying weight for the battery and the screen. And then your screen size sucks. It's like, yeah. Sixteen by 9 is good for games. I guess like it's probably better than 4x3 for games because you get more peripheral vision. But by the same token, if cinema is wider than 16 by 9, then why shouldn't games be wider than 16 by 9? If the point is moving images that fill your peripheral vision, then 16 by 9 is too short, probably. Have I tried the small taskbar icons option? Yes, I still didn't like it. Why do companies like Twitter have giant teams if the software is so simple to write and would need to change in order for companies to prefer what would need to change in order for companies to prefer smaller teams of good programmers? The problem is just the economic model, all right? So companies like Twitter and whatever do not succeed or fail based on how well they can write software. That's just period, right? They succeed or fail based on whether they had the right product idea and the right luck to capture some market segment in the internet, right? And then once you get that, it's like a giant waterfall of money. So you have all this money to spend on programmers, right? And then there's this second order effect where because so many companies have done this, the standard for what is a programmer has just fallen precipitously because we've had decades of not caring whether people can really program, right? I mean, this sort of started in the first .com boom, but got much worse in the second one. So, like, I don't know what else to say about it. Like, that's just going to be how it is until the economics change, till it becomes harder, till it matters more if you program well. You think the managers would just fire everyone except for the 10Xer? No. So the thing is, managers want to build their fiefdom because the more people they have under their control, the bigger their budget, and the more likely they are to get promoted. Who are you going to promote to VP? The guy who runs some dinky group of 3 people, or the guy who runs the 200-person division, right? So managers, and there's also an ego thing of how many people they manage. So the incentive for managers is always to grow their groups as well. And yeah, it's not like the manager gets paid money personally if they don't hire people, right? So you think most of the FANG companies can program? I disagree. I disagree. I mean, some people at those companies can program, but the standard has been declining. Even so, I have some friends who were Google employees. Actually, one of them is still a Google employee. In like 2006, 2007, I met them, and they were pretty reasonable people who could actually program to a good degree. Google employees of 2020, no, like it's a whole different thing. Like it's just gone downhill is all I'm saying. The timer on your phone no longer alerts you when it finished. It just goes into negative time. Yeah, that was probably too hard to program. Where would you advise people to work where they are allowed to put time into writing quality software? Well, I don't know. I do not know. You kind of just have to find that opportunity yourself. It's not like I know of a big company that focuses on that, right? How does something like that go downhill? Well, you can always find reasons why you need to hire more people, especially if you're a manager and you're incentivized to spend your budget, right, on people. So the more people you hire, it's like supply and demand, right? The more people you hire for a given supply, or the higher the demand is for the given supply, the more you can't just take the absolute best, right? Because there aren't enough of those people. Right? And then once the standard goes down and for long enough that everybody has lived in that environment, then there's no reason to think the standard should be higher. You know what I mean? Because you're acculturated to thinking that programming is a certain thing. How would you be able to check if you can program? Well, the great thing about computers is the computer tells you if you can program. It's not my opinion, right? It's like, what can you make the computer do relative to what other people can make the computer do? That's all. Like, programming is objective in that way. Do I agree that learning theoretical CS is useless because Stack Overflow already knows the answers to all problems? No, Stack Overflow does not know the answer to all problems. Many answers on Stack Overflow are wrong. Many of the ones that are not technically wrong are kind of clueless or like inefficient answers or clumsy answers, right? Also, some parts of theoretical CS are really important. Not all of it. A significant amount of it is a waste of time, but some of it is really important. No, programmers who just go to Stack Overflow all the time, you don't want to hire those people. That's a red flag. Is it more important to keep cache locality or keep algorithms at O1 till O n log n? It depends very much on what n is. If n is greater than 2, you might think about n more than cache locality. Not if n is greater than 2. You could go up to n squared and still care about cache, at least, if n is small or medium sized. Like n squared for 1,000 items is not even that much for a modern computer, right? The question is just, if n is like 1,000,000 or 1,000,000,000, then you might start caring. It just depends on your particular application. I can't give a general number. All right, I got to get back to programming, guys. The questions are getting very generalized. All right. Yeah, somebody is giving a search term that you might use to get my opinion on CS School. We did chai last night. We did chai latte last night. It was good. Yeah, this is what I get for streaming at a Europe-friendly time. It's true. It's true. I mean, you could watch the VOD from last night and see some chai. I'm sure that'll be good. Okay. What are we doing here? We're trying to figure out. It's been 20 minutes of questions. So the game works, right? So what are we even doing? Oh, I was just running this to get the debugger open, right? That's all. Okay. So LLVM needs to work now. And I started doing it before, but it's not quite right. Okay? Like using the LLVM API is like it's like playing a Zachtronics game because everything is super weird and constrained and limited. But it's like a Zachtronics game designed by Debbie Downer or like, I don't know, someone really depressing. Okay. So we get our int compares, we icomp. Okay. If they're not equal, okay. We have to just do a bunch of crap here. Can we put a select? Like, can I use a select? It probably doesn't make sense to put a bunch of if-thens inside a select. So I probably just need to start busting out the if-thens, which sucks. Like, that's going to be a nightmare. I mean, I could do it anyway and let LLVM just optimize it. Let me try, oh no, short circuit and happens above this. I'm really not looking forward to this. Okay. Okay. What am I doing? Maybe I've got the new California Super COVID. Okay. Let's try making selects So this is going to be the count condition. And then we're going to do the data condition. Is going to be icomp EQ of data A and data B. All right. So we're going to have a couple of selects. So we're going to create a select for count cond as the condition, right? And if that's false, we're going to go to the null value of desc type. Otherwise, we're going to go to select middle. Select middle is going to say, are the data pointers equal? If they are, then we actually want this. We want a true result. Okay. Or the memcomp result. Now the memcomp result is a giant pain in the ass. Because, okay, so these selects don't short circuit. So I can't actually do a select for data cond. Is there like a ternary operator in LLVM API? That's what I want, is the C conditional operator. Oh, that's Clang. Yeah, that'd be just useless to us. Okay. Whether it becomes CMove or branch happens late. Is that true? Like, the problem is I need to be guaranteed that it's a branch in the second case here. So I can't use select, right? I have to actually make branches, which probably means I have to make basic blocks and shit. Like, I don't even know. Like, this might be a complete disaster. Select is resolved in the code gen, but no. How do I tell it? How do I tell it it has to short circuit? Is there a way to do that? Why does Utah have a copy? Create select. What does MD from mean? Of course, there's not going to be any documentation. What is MD from? Oh, and then it's true and false. So I had this in the wrong order. Wait. Oh, no, that's true. That was in the wrong order. Actually, let's do this. No, it was in the right order. I just had it. Okay. Okay. Select doesn't short circuit. Right. So how do I short circuit? Without doing a nightmare of creating a billion basic blocks. And like the problem is we have a higher level thing that also creates basic blocks, and like making those work together with LLVM's awful error reporting. Yeah, right. So that's what I'm saying is select is not for short circuit. So I cannot use it here. Or I can use it for part of this, but I can't like this is such a disaster. If you definitely want short circuit, you have to do the explicit branch route. Yeah. Okay, well, rip this stream because we might not ever be able to finish this. You don't see this as a problem with LLVM? No, it totally is, because there's no goddamn documentation. There's no goddamn examples. It's absolutely a problem with LLVM. I will ban anyone who says it isn't. I am very angry about the amount of my time LLVM has wasted. Very angry. Sorry, I'm just not even gonna entertain sarcasm on this issue. I need to keep my quality of life high. The thing about short circuit requiring branches is not, well, by the time you see how much of a headache it is going to be to do manual branching, you might change your mind. As far as I can tell, it's probably a nightmare. Whereas it probably should just be a flag on select or something. Okay. I almost don't even want to do this. I almost just want to delete the LLVM backend. I'm so angry right now. Well, angry / frustrated. I literally almost just want to delete LLVM from the project. It would solve so many problems. If I just delete LLVM and say, sorry guys, no more good code generation till later, when we make our own optimizer, that would make me so much more happy in terms of my quality of life. The problem is we just hose the Sokoban game till then. Bad business decision stream, yeah. I would be so happy to delete this. Look, it's only 5,000 lines of code. Could delete that. Yeah, if I delete this, we probably go down to under 50,000 lines, right? That's appealing. It's almost exactly the right size. It's 5383. This is 5341. So we would be down below 50 again. Okay, let me see. Maybe there's some code in here that could be repurposed. Nope. What even is that? Why are we creating branches out here? That seems weird. Okay. Is there something besides create burr? Create cond burr. I guess that's what I need is create cond burr. The question is, can I make, the whole issue is, can I make sub basic blocks local to this code that that the top level doesn't really know about? And the problem is, we need to make a successor. Okay. I think, so what we do is, I think we make a successor block if we see these instructions. So we could say, we know there's a branch in here and make a successor block if we see this instruction. And I think that'll work for now. This whole, like I said, this whole instruction index by block thing is nasty like the honey badger. So we're going to have to change that eventually. But in the short term, I think this will work. Okay, so let's do it. So, okay, we have count L value A, count L value B. We're just going to cond burr all of them. Select top is going to be create cond burr. Burr. Create cond burr. Can I no, I could select with a branch on the inside, right? And then I can make a successor. What a disaster. Okay, so okay, cast bounds check. Right. Yes, okay. That's okay, this makes sense. So cast bounds check does the same thing, and we can use that as a template, or array bounds check is probably better. I forgot about these. Okay. So our bacon is saved because we actually have an example to work from. So yeah, so we can fall through at the end, which is one question that I had. This is fine. So we're going to go, here we go. We're going to say count equal block is basic block create. Okay. So we have count equal block. And then we create cond_bur. I mean, the problem is actually we want a select for the top. We just can't do that though. Like, how do I assign to a frickin' value? I mean, I guess we use our thing. Okay. We're just going to make, okay. Such a disaster. Okay, strings are equal block. Strings are not equal block. Okay. And then how do we put stuff in those blocks? We set insert point. We'll do this at the end. Oh, we can't. We need to make the, okay. We need to make the blocks above. And then we need to set the insert point. Okay. Okay. So strings are equal block. So we're going to say okay. So So when we define 1 up here, we're also going to define 0. Like that. And then all right, we'll put this way up at the top. Like that. Wait, why don't I just do this? Because we know that type. All right. Okay, so back down here, value knotted. If strings are equal, we want to return 1, otherwise 0, right? And then down here, we do it again for strings are not equal block. And we do that. We create a store. And then we just fall through to the successor block, which I think it'll just do. Okay. So, and then I think our main loop will set the insert point back. Hopefully. Okay. So that's that. This is this. Now we start dealing with the mess. We get the counts. We create our strings are equal and not equal blocks. We might as well do that because that's up there. Okay. So we're going to say count cond is A is equal to B. Counts are equal block is going to be this. Okay. This seems fishy. Okay. So we're going to create a cond bur. So we just say which blocks to go to. That's fine. Okay, so if the counts are equal, we go to counts are equal block. Otherwise, we go to, if they're not equal, we go to strings are not equal block. All right, great. Okay. Now we need to fill counts are equal block. Okay, and then that starts doing some of this stuff. So we go data, 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 data. Are the data pointers equal? So then we create a cond bur. Between data for data cond. Are the data pointers equal? Then we go to strings are equal block. Otherwise, we go to perform memcomp block, which we need to create up here. And the reason I'm saying these are fishy is like, I don't know what this is. If this is like successor, I don't know if it's default successor or like what the, we need to look at that. Anyway, perform memcomp block. Bam, okay. So we're going to fill that out. Perform memcomp block. Okay. Memcomp func result is 0, casted memcomp result. Actually, we don't want that. So if memcomp is 0, then we cond bur, well, we cond bur again. We say create cond bur is 0, strings are equal, strings are not equal. All right. Okay, so we kind of don't need this. Okay, probably I made several mistakes here. Let's look up what basic block create. Let's see if we can even figure out from this wonderful documentation. Creates a new basic block. If the parent parameter is specified, automatically inserted either at the end of the function or before the specified basic block. So that's insert before. Okay. Yeah, so that's fine. The problem is, okay, the problem is we need to make these last. Actually, no, because this will fall through to this. We're just going to put jumps. And then it doesn't matter, and we'll just say that it optimized. Create bur. Yeah. Create bur next block. Okay. All right. Review. We have a 1, we have a 0. We could try putting desk type here. Hopefully that works. If it doesn't work, we need to think about something probably anyway. So we get the next block, which hopefully got created by our outer loop. We make 4 blocks. Strings are equal, strings are not equal, counts are equal, perform memcomp. They all get inserted before this thing, and I guess it's, you know, this gets inserted, so that's at the end, or no, I guess it goes in this order. It's just tacking these things on the end, so probably for sanity's sake, we want these. Okay, so it doesn't really matter because LLVM is going to use UB to launch the nukes anyway, but it is what it is. Okay, so we get the L values of the counts via this long and amazing process. We create loads. To get the counts. We compare them. We go to either equal or the strings are not equal. Okay. Counts are equal or strings are not equal. Counts are equal says, hey, we load the data pointers. So I feel like actually we're going to need to cast down here or something. Because these are I64 pointers. Which means these are I64s. Which technically memcomp is not going to like. Right? Anyway, so icomp equal data A, data B. If data pointers are equal, strings are equal. Otherwise, we perform the memcomp. Okay. And then we do the memcomp. Like, why is that a separate line? I don't know. We say, is it equal to 0? And we go to one of these. Okay, great. Now, the other place that does memcomp, which is our actual intrinsic implementation, mem A and mem B, those are going to be pointers. So I probably need to do a pointer comparison. How do I compare pointers in LLVM? These probably need to be I8. We need to make this even longer. Get pointer 2, get pointer 2. Oh, do we have a PI8? Oh, yeah. Oh, that's the good stuff. Okay. If pointer 1 not equal to pointer 2. No, that's not going to work, dude. Is it create pcomp? No. LVM IR builder create pointer compare. How to compare pointers. Create putter diff. Okay. Create putter diff. Okay. So we create the putter diff and if the difference is 0, if we actually want to do, wait, no, if the difference is 0, the strings are equal. Okay. Okay, now our problem is the perform memcomp needs access to these variables, so we can't do these braces. Because we need data A and data B, which we only grabbed up here. Okay, let's see how many compile errors we have. Last time you used LLVM, you decided to just emit the textual IR directly because the API is such garbage. Yeah, I was going to do that initially. Oh my God, it compiled. That was my initial approach. And it didn't work because all the LLVM tools crashed on my output and provided no information about why they didn't like the input. And then B, it's also just slower to do that probably. But yeah, it's complete garbage. I would probably be happier in my day-to-day life if we weren't using the API, for sure. Oh, not x64, LLVM. Actually, let's do this one. Okay. May only branch on Boolean predicates. Okay. You can't take a pointer diff. Guys. Why was I so foolish as to think that you could just create a pointer diff and then use that? That's silly. Is there no pointer equal? No, we literally have to create a pointer diff and then cast it. We have to say, is it equal to 0? Instead of just comparing pointers. Is it not equal to 0? Right? So that'll give me an I1 if my LLVM foo. Why does all open source stuff just have awful documentation? Because open source people hate humanity, as far as I can tell. You just do a regular compare just to types or pointers? No, I don't believe that that's true. I don't think you can do that with this API. You might be able to do that textually and it translates it into whatever. But I think if I do a create icomp, it'll crash. You can use the normal compare if you turn them into ints. Yeah, but if I turn them into ints, then I can't use them in the memcomp, right? So I either have to cast twice or cast once. Whoever made this API just loves casts. They love casts and inefficiency. All right, well, okay. It builds, however, it thinks all strings are not equal, including the identity string. So that's great. This is actually better than it could have been, okay? Because it could have been, we have to fight for hours through a zillion cast errors. But that's not what it did. So let me make sure my 1 value is actually 1. Okay, that's great. Okay, what is wrong with this logic? So the thing is, to figure out if things are equal, we have to go all the way to the memcomp. So we could figure out if the problem is the memcomp somehow or not. Like we could do this. That's a very stupid thing to do, but it's basically if we get to the memcomp, the strings are always equal, and we'll see if that changes the outcome. No. So we don't even get to the memcomp. That is my conclusion here. Or maybe something happens afterward that invalidates it. How about if we just step in and see what it does? Okay. I mean, like, I don't even know what we're even testing. What are these ads and CQOs? An IDIV? Why is there an IDIV? Why is LLVM generating an IDIV? Or maybe we did that. Like, do we not like break down here? No, we do break. Like, what? What am I even looking at? Okay, that seems wrong. Let's see. Okay, it jumps to the next instruction. That's high quality code gen. Is this even LLVM output? I guess it is. It just looks too spammy. I'm like, how could it be? All right, I'm not even going to try to understand this. I have no idea what's going on here. This does not look like the code that we outputted at all. We certainly never get to the memcomp, though. All right. Let's break it back down. Now that we have all of this, let's break it back down. So let's just compare counts. Look, if the counts are equal, strings are equal. If the counts are not equal, strings are not equal. All right. If strings are equal, then so knotted is going to be false. So value is 1. We store value in the result. We go to next block. All right. Let's just see what happens there. Oh, I might have forgot to recompile the compiler last time, guys. So that check may have been invalidated. Okay. Like what? Okay, here's one. Here's a good one, guys. All strings are equal. I bet you didn't know that. I bet you didn't know that. Create BER. Strings are equal block. Okay. Is that getting knotted somehow? Type bool is I8, which is what I thought. All right, this is very mysterious to me. How about if we do this? Bytecode strings are equal. Just throw away all our wonderful work from the last hour. Is you just create a store of 1. The end. Every string is sacred. Okay. Okay, this is weird though. I already don't understand. Wait. See. Oh, right. It's okay. It's equal and not equal every time. That's fine. This makes sense. Now, if I put the knotted up here, then these should at least match every time, which they're supposed to. They'll all say equal. All right, but we're testing. We're just learning. We're just learning. Okay, so we put value. All right. Oh, we need knotted. Actually, let's leave those down there because we're going to delete this. So wait, now they're always not equal? Oh, because... Right. And now they should be always equal. Okay. So strings are equal should be knotted 0:1, which it is. Okay. So this is okay. So why then, why is this effed? If we just jump to, okay, what if I put this branch in? Right? Is that what's hosing us somehow? No. If I knot the knotted, it'll reverse that condition. Okay. This is all fine. Okay, so let's start doing all this stuff. We're going to create these blocks, but we're going to do our same thing down here. Bam. Okay. Next block. Oh, because I've got it twice. Okay. This is doing what we expect. Now, let's fill out strings are equal block and strings are not equal block. Still, let's make an underscore knotted here. Still no change. Nothing too surprising. Still doing what we expect. Okay. Now, what if we do this? This should be the same. I feel like this is going to break for some reason that I don't get. Nope. And if we go to not equal block, I should toggle it. Okay. So strings are equal block works. Strings are not equal block works. This works. Okay. So now it starts getting dicey. What do we do here? We say it's probably these gaps are wrong. Because again, it's LLVM is impossible to understand. Probably the gaps are incorrect. And then probably I forgot to recompile the compiler when I did this. Okay, so let's try this again. This is not going to work. Oh, wait. Take that out. Okay. This should maybe work though now? Question mark. If the gaps are wrong, that should still work. If we always, yes, okay. So the gaps are incorrect here, which is completely unsurprising. Oh, because this is the wrong type. Right? This isn't the type of the result. This is the type of the array element. Oh, no, wait. This is a cat. Oh, never mind. This is the gap. Okay. This is, we're casting the type of the gap to a thing. I don't know. I mean, that looks right. What if we compare A to A? What if we ask Ayn Rand, is A? And she says A is A. And B is also, but A is never equal to B, apparently. Which also Ayn Rand would say A is not B. So we've determined that LLVM is extremely objectivist. Do I have similar gaps? Yeah, I thought so when I copied this one. Why shouldn't it just be cast to I64? Okay, so this thing, these registers of whatever are actually L values. And we store into them to finish. So we do the gap by a certain offset. Oh. These might not be PI8s. Maybe they are. Oh, it shouldn't matter. Guys, string count offset is 0. Which is the wonderful irony of all this code. By the way, you'll note that somehow the LLVM version is taking more time than all the rest of the implementation put together magically. So if the GEPs were super wrong, I would expect to crash. So I kind of don't know what to do. However, now that we've simplified this down, maybe we can step through it again and try to see what it's doing. That might be a thing. Okay, so we always think not equal for some reason. All right. If A is equal to B. So we move RAX. That's probably the count of one of the strings, right? That's a data pointer, dude. Yeah, this is actually the L value of the frickin' string. So this GEP is giving us the address of the... What? Do I have to like use the array form of GEP? I don't know. And what's the difference between create GEP and what's the other one? Create get element. Hold on. There's get element pointer. Like, when do I use get element pointer? Or sorry, get element putter. Like, I have no idea. I have literally no idea. I guess this is just what we do when it's a constant, which this wouldn't be. But, like, are these different? I don't know. Bitcast is wrong on the I64 get pointer 2. Someone is saying. Why? Explain why. Casting pointer to I64. What are you talking about? Helper I64 get pointer to is a pointer to I64. We're casting to pointer to I64. And that doesn't even matter. The casting is not the problem because we have the wrong value. We're somehow... Yeah. Like, is there some... Maybe I keep getting confused about what this is. What's a thing? You think I'm doing something like I64 and string 0? What? No. I don't understand why you say I'm casting to I64, because that is literally not happening. Ampersand string 0, that would explain the results. Actually, no, it wouldn't, because ampersand string of 0 is equal to string. What about the constant type get type? This is LLVM nonsense. In order to pass a number that provides the offset for the gep, you can't just say string count offset. You have to do this. You have to actually create a constant int. There's no version, because it wants a value. As far as I know, there's no version where you just like pass the argument. Okay. So if we're doing ampersand string sub 0, let me just look at array subscript, because that's what this is, right? Load plus offset. Oh God, guys, yeah. I forgot a level of indirection. Okay. Yeah, I'm stupid. I can't program. It's fine. It's fine. I just spent half an hour on the fact that I can't program. So this is an L value, right? Like I was saying, that is correct. In our representation, strings are also L values, or sort of. They point to stack areas explicitly in our representation. So we're going through LLVM's representation, then we have to go through our representation to get to the frickin' value. Okay, so the deal is just we have to do this. So we load that, we make sure it's a pointer. And then these are just RA and RB. And then down here, these also shall be RA and RB, right? Okay, That's good. So now strings are equal when the lengths are equal, and they're not equal when the lengths are not equal. Let's verify that, right? So now I wish I'd done this in a terser format. So these are equal. This is not equal because the length is different. But heli is equal to hello because they're both 5 characters. Okay, we're in business now. So all we have to do is go back here in theory and change this to RA and RB. Nope, didn't work. Does that mean the memcomp doesn't work somehow? Oh no, because this, remember this? This isn't strings are equal block. This is perform. Oh, counts are equal block. Wait, is that what it was? No. Somehow I didn't put a tag on that was a goofball. Still not working. So we're sort of saying the memcomp always succeeds. So we load data A, we load data B. Is program whiz correct? No, I don't think so. Like the GEP was actually fine. It's that, like that GEP was fine if register A was the base of the array. The problem is it wasn't the base of the array. It still says strings are not equal block. Yeah, that's correct. If the counts are not equal, the strings are not equal. That's correct. So if the counts are equal, we do the GEP. We create the load. This whole pointer diff thing, I might actually do this where we cast it to an integer. Is the pointer diff not equal to 0? Oh. Hold on. For this test program, we could actually take out the pointer diff, because one of the functions of the pointer diff is to compare against null, right? Okay, this is kind of wrong here. It's actually, hold on. If pointer diff is 0, then strings are equal, so it's true. Okay, that was incorrect. String data offset is not 0. Is that still fine? Yeah, it should be, because I casted to PI8. Hey, everybody. Maybe that works. The saddest part is we barely got any Weissman score out of that, but it's a good thing for the compiler generally. Is it even possible to wrap the gap? I mean, probably not. Maybe. Maybe. Well, that passed. Let's try the game. Yeah, I mean, the issue in that particular case wasn't the GEP itself. The GEP itself was correct. And I think that's because, like, I've been using LLVM enough now that I kind of generally know how it goes, even though it's weird. The problem is just because things are complicated, my level of assurance, right? Like, my morale that my understanding that the GEP is correct is like not very high, right? Because there's just so many levels of indirection and layers of crap. And it's just so easy to get something wrong. So that's sort of the thing, is when you're trying to figure out what the problem is, you use how sure you are that various things are right or wrong in order to guide your solution finding process, right? And if you're not very sure, that could be hard. All right. Anyway, so I'm glad that we got through that. And we got rid of all the string comparison call stuff. So that's nice. Our Weissman score is not much better than it was, but it is slightly better. So I will take the upgrade on the scoreboard. Well, that was... Wait. Three two five four five nine, 325 472. 458. We'll do the 59 just so we can feel good about ourselves. So that is a Weissman score improvement, but it is not a massive one. But I feel much better about strings in the programming language. Yeah. Look how small that is now. So it was 18 megabytes before we started any of this. So that's like 20% down, right? About, yeah. So that's cool. Yes. There are other gains that we could do. What I'm deciding is if I want to take a break and come back later, because honestly, LLVM is tiring. It's been 3 hours. We got our gain though. That's pretty good. We could do preliminary investigation of the next gain. Well, let me check this in. Let me make sure that release build works. That's great. So committing. Let me change the way that I is now built into the compiler with its own bytecode instruction. Okay. Bam. So good. Okay. So good. I have 2 possible places to look for gains, and then we might be done with gains in the near future. Because the next gains for x64, at some point, the real gains come from putting an actual register allocator in there as opposed to my temporary stupid one. That would mean designing a register allocator, which would be fun. But maybe it's not something I want to do in the near future. Like maybe the near future thing is go to the mailbag, fix bugs for the people in the beta, and ship the beta. That might be what we do this evening. I mean, honestly, I should test all this stuff on Linux to make sure it actually runs. But because there's been so many changes. This is massive, though. Like, it's been really good. More LLVM fun. No, I'm done with LLVM for the day. That actually was less painful than it could have been because we'd already had the infrastructure in place that Josh made, which is not ideal in some ways. We're going to have to change it, but at least that was there and took care of the basic block problem for us. Like, the fact that it already had a way of making a successor block that we could branch to was good. That saved our bacon there. Otherwise, it could have been a complete disaster. Would a vararg method trampoline make sense? Vararg method trampoline. I mean, this sounds... You use the word method, so... I don't even know what you mean. Do you mean object-oriented? Like, what do you mean? I think he just wants a trampoline. Well, we're not going to put a trampoline in. That's not a thing. Yesterday I was surprised there wasn't more dead code removal with import basic. Did I look into that? I have not yet looked into that. It is on this piece of paper here. Should I look into that next? Maybe. Honestly, guys, I'm tired, so I'm going to take a break. think about what to do, and we'll do another stream later on. Yeah, LLVM just drains me emotionally, like having to deal with it. It just So we're gonna come back later, but let me look for a science and technology streamer that we can send you all to. Lana's not doing programming. Too bad for her. Chemistry. Becoming a UX researcher. We did Jessica Mack recently. Hard physics platformer, number 130.
I think I've finished the
Could
last level in
could do that. Raspberry Pi. We could do some Raspberry Pi. All right. Thanks, everyone. See you later. See you later.